And this calculation is still optimized because we are not calculating world space view vector twice, because this code will only be executed when this code will be off. So now we have all our parameters that we want to pass to our IBL reflect function. Second change we will make is we will add the result, because when the basic lighting is off, we want our object to have an overall reflective look. So we will add it all over the surface. And we are now storing the result in O.surfaceColor. But let's check where we have declared our O.surfaceColor. We have declared our O.surfaceColor only when the vertex lighting is on. When the vertex lighting is off, there is no existence of surface color. So here as well, we will add an extra else condition. If vertex lighting is off and IBL reflection mode is on, only then declare IBL color. So once we do that, we will have surface color available in complete Vertex Shader code. Now, there is one more thing that is remaining that we will have to fix, and it's a bug in our shader. It will not give us a compilation error, but it will give us a visual bug. If you take a look at the calculation of world space view direction, it depends on underscore world space camera position, which is a variable that is given to us by Unity. And we need O.position world. And where we are calculating O.position world is inside the vertex lighting. When the vertex lighting is turned off, this variable doesn't have the accurate values. So we will take this line out. Instead of cutting this line, we will just comment out this line so that you remember that this is the mistake that we have made. And bring it outside this code, because whether the vertex lighting is on or off, we will need this variable which has the proper calculated values. And this is also a bug that we left in our specular reflection shader. So I will fix that shader and comment out this line, and I will add a note that this shader is fixed in IBL reflection chapter. So this way we have completed the modification that are required for Vertex Shader. So let's save this shader and see what it does in Unity. To make sure that what we have changed, we will change the values here. We will go to the Vertex Shader and see the effect. We have switched the lighting mode to the Vertex Shader. That means our vertex code is compiled, and now we will turn on the reflection. And there is an error that is on line 153 that cannot convert from vector 3 to vector 4. And the problem is IBL reflection is giving us a float 3 value and O.surfaceColor is a float 4 value. So we will apply .rgb here in both the places. Let's save it and go back to Unity. That fixes the problem, and let's turn off the lighting and keep the reflections on. So that's how we have made sure that what we have done in our Vertex Shader is correct. Now it's turn to modify our Fragment Shader. So let's go to our Fragment Shader. And in the Fragment Shader as well, we have the condition whether fragment lighting is turned on or the fragment lighting is turned off. So we will have to add another condition if underscore IBL mode underscore REFL is on. Then do something, and similarly when the fragment lighting is turned off, and IBL reflection is turned on, then do something. So one thing that we will change in this shader at this point, because we are adding more and more conditions in our functions. If you see here that at every single condition, we are returning a float 4 color. And if we will add few more conditions, we will have to add few more returns, and it gets overwhelming at a certain point. So to make it simple, we will declare a color variable on top, and at every step we will keep on multiplying or adding the effect of that particular reflection and store it in the final color. So before use normal, at the first point of this fragment shader, let's declare this variable float for final color, and it will be a float 4 type value because it will return R, G, B, and A. And then the first point where we are returning our color is when the ambient mode is on, and when the ambient mode is turned off, this is the calculation. The only difference between these two calculations is that we are adding the ambient color in one, and this is our basic calculation in both.